All right, welcome. We'll get started here in a little bit. Um, um, all right, so put that in the chat just so there is record of it. Please make sure that you sign in to chat. You just have to say something. Doesn't particularly matter what it is. Most people say here. And our fourth test is coming up. It will open today, later this evening, but we're not doing the official review for it until Monday. So we're finishing up our last little bits on vectors today, and then we will be doing, like I said, our test 4 review on Monday, and we will be doing review for the final exam on Wednesday and Friday. So keep an eye out for that to pop up, but it will be due most likely next Sunday night. So I highly suggest you do not wait until next Sunday night, especially for your first attempt, because yeah, that's not going to go well. If you waited that long and then have issues, it's tough to first of all fix them, and second of all, I mean, don't wait that long. We'll just stick with that. So we'll talk more about specifics on Monday, but if you're feeling frisky and want to go ahead and get it out of the way, then more power to you. All right. So this is where we ended off on Wednesday. And we took a vector, A, in component form, 3 in the x direction, 4 in the y direction. We found its magnitude happened to be 5. And just for giggles, I divided that vector by its magnitude, and we get this thing. And this thing is very important when it comes to talking about vectors. But first off, let's look at what the magnitude of this thing is. So you could do it the old-fashioned way, like taking these, squaring them, adding them, taking the square root. Or you can take what we know about magnitudes of vectors in general, and the magnitude of A over C is the magnitude of A over the absolute value of C. But in this case, the thing we're dividing by is C, or I'm sorry, is the magnitude of A. And what is the magnitude of A divided by the magnitude of A? Should be a softball to start the day off easy. What is the magnitude of A divided by the magnitude of A? Anybody? Well, it's going to be a very interesting class today. Somebody, anybody?
Does that equal 1?
I'm sorry, you were breaking up. Whoever was just speaking.
Does it equal 1?
It equals 1. Any number over itself is always 1. So you can do 5 over 5, actually plugging it in if you wanted to. But it equals 1. Woo, okay. So this has a very particular quality. And it kind of rounds out all that we know about vectors. So a vector divided by its magnitude is defined to be A with a little caret on top. And this is a special kind of vector. Is a unit vector. So a unit vector is a vector that has a magnitude of 1. And this is kind of how we describe units in general, actually. Like if you're talking about a speed, it is a distance per unit time. So let's say you're traveling 55. What is the unit?
Miles per hour.
Miles per hour. So it's 1 mile or 1 hour. So this unit vector, this thing has it doesn't have a magnitude really. It just has a kind of a description. And we're kind of getting into higher thought terms. But an hour is kind of in a different direction than a mile. Hours are only in the time direction, and miles are only in the distance direction. So a unit vector has only direction. Basically, A with a caret is a vector that points in the same direction as A, but is only 1 unit long. And it just kind of depends on, what the units you're talking about are, but it could be meters or feet or whatever. But the idea is that it's all direction. So a unit vector has a magnitude of 1 and is all direction. So this kind of comes full circle back to our 2 ways of talking about things is component form and magnitude and direction. So you could say that A equals AX, AY. Most everybody's gotten pretty comfortable with that. But the other way of describing this is in terms of its magnitude and its direction. So let's figure out a little bit more about this thing. It's kind of weird to think about because up till now, whenever I talk about magnitude and direction, when I say direction, what am I usually talking about? I say AX, AY, A, and not this. What's the other thing that usually goes with the rest of these? That tells us the direction of a thing. Where's my... What's the other thing that goes with magnitude and direction?
Is it theta?
Theta, yeah. So, but now we have this other thing that's supposed to take the place of theta, because there wasn't really anything that we could do with theta. All right, so back to our triangle. This is all for vector A. A X, A Y, and A. So what is the magnitude of this one again? It's one we just did on the other page.
Is it 5?
It's 5. Yeah. Okay. So on this little picture, where would theta be?
Would it be the point where the AX and AY come together?
No, because remember, X and Y are always 90 degrees apart. So that's one of the things that allows us to do these things is that AX and AY make a right triangle. So you've got two options, here and here.
Why would it be 2 theta if it's only going in one direction?
I'm sorry?
Did you say there was 2 thetas in there?
No, I'm saying you have two
Oh.
options. Only one of them is theta.
Now y'all. I would say this corner right here, the AX line, like right there, since the arrow's already going in that direction.
This one is theta. So this is back from way, start of the semester when we defined cosine of theta. What does cosine of theta equal?
Is that 3/5?
Well, you're skipping a little bit ahead, but yeah, it's AX over A. What about sine?
4/5.
AY over A. Okay. So A vector over A equals a x a y over A. But that equals a x over A, a y over A. All right, so I haven't done anything crazy here. But let's take these two ends of this little equation, this one and this one, and continue them out one step further. What does AX over A equal? Not numbers wise.
Three-fifths.
I said not numbers wise. So I know y'all like to see the numbers, but not the numbers. It does equal 3/5, but that's not the direction I'm going. Look at the other side. What does a y over A equal?
Sine theta.
Sine theta. Okay, now you would be right that it's 3/5 and 4/5, but we're trying to get a general case here. Okay, so let's take this one now a step back. What did we say this is the definition of? And I guess we could say that I don't like doing it this way because it's extra. And you should know that this is not the vector because it has, it doesn't have a little thingy on top of it. But what is this, the definition of? Hint, it's something that we just defined like 5 minutes ago. What did we just define 5 minutes ago?
The direction.
The direction, but what do we call it?
Theta.
No, because theta is a number. Theta is an angle, it's a number. What new thing did we define today?
The unit vector?
The unit vector, yeah. So this is how theta gets used to actually kind of tell you the direction. And it's in this setup of the unit vector, where the unit vector is, x component is cosine of the angle, and the y component is the sine of the angle. So this brings back kind of to the beginning how we talk about these things. We have the component form, which is x and y, or we can split it up into the magnitude of the thing and an arrow that points in the direction of this vector. So in this case, this is all magnitude and all direction. This case, this is x component and the y component. Okay. So using this new little definition, not definition, but relationship, I guess. What is the magnitude of A? I'm sorry, A hat. What's the formula for magnitude of a vector?
R squared equals R squared plus Y squared.
Okay. So the square root of the x squared plus the y squared what is cosine squared plus sine squared?
One.
1. And what is the square root of 1?
1.
Very good. Yeah, so this is our Pythagorean identity that we talked about the last 2 sections. So it pops back up. So further proving that it does not matter what the angle is, right? So I didn't have to plug anything in for theta. It doesn't matter what it is. Cosine of an angle squared plus sine of an angle squared is always 1. Proving that this unit vector always has a magnitude of 1. No matter what. So this is the nice bit about unit vectors. So now we have pretty much all of the basic bits and components of vectors. We have the component form, we have the magnitude and direction form, and then this is another definition of the unit vector. So let's see. Not really going to have a enough time to finish up what I wanted to, so just know that there are we did scalar multiplication, but there is a different kind of vector multiplication where you multiply two vectors together, and that's going to come up. I'm sure you all will do a review once you get to calculus, but that's the next step, is multiplying two vectors together. We won't get into that because that's probably a whole day on itself. So let's just do an example with these tools that we have here.
Dr. D, I just have a quick question real quick.
Yeah.
So when you do, like when you multiply two vectors together, would you ever use tangent?
No, not really. I don't want to get too far into it, just because it is kind of a crazy thing, requires some setup, but you generally, when you multiply vectors together, there are two different ways to do it. There's actually two different kinds of multiplication. There's a dot product and a cross product. And they mean very different things, but this one uses the short version is, this is magnitude of A, magnitude of B, cosine theta. This is magnitude A, B, sine theta. So in this case, theta is the angle between his angle and his angle. And same thing over there, it's the angle between his angle and his angle. Like I said, this is extra stuff, don't read too much into it. But short answer is the two different kinds of multiplication. One of them uses cosine of an angle, the other one uses sine of an angle. So they don't really use tangent. But yeah, and this one is pretty straightforward. The cross product is actually nasty once you get into it. So if you'd like to talk more about it, I'm happy to, but I don't want to hurt anyone else's brain. So we're going to do a quick example. And I'll just show the picture to you. So find, oh, come on. Find the component form of a vector that represents the velocity of an airplane descending at a speed of 150 miles an hour at an angle 20 degrees below the horizontal. So this is one of those examples where we have four different things. We have magnitude of A, angle of A, AX, and AY. So I said that of these four things, I should be able to give you any two of them, and you should be able to find the other two. So which two did they give us?
Can you click back to that screen?
I can.
AX for 1.
Nope.
Okay.
So first off, there's only one of them that looks like that. Only one of these four things is that. Which is it?
Talking about the angle?
The angle. So the only thing that is an angle is theta. So theta equals 200 degrees. What is the other thing that they gave us? Did they give us the magnitude of the vector? Did they give us the x component or the y components?
Is that A that they gave us?
Yes, they gave us the magnitude of the vector. A equals 150. So, what are the, and we're probably gonna run out of time, but so be it. What does AX equal to? What is the X component always equal to? So, just because we're gonna run out of time. So to find the components, you just plug these two numbers into here, and you get what you need. So we're about to get cut. I will send out an email about the tests and such